a little bit easier form to use than what's given in the flow chart there. Either way, I just use this version because that's easier to plug into my calculator. So Z naught is x bar minus mu naught times the square root of the sample size divided by the standard deviation. Now, here's what's given in the problem. So I need given statistics to plug into this. And if you read the problem, it says to test this claim, a random sample of 106 humans was obtained. So that means the sample size for this test is 106. That's the number of humans we picked randomly to be in the study. And it says, of those 106 humans, it was determined that the mean body temperature for the sample, this is the sample mean of the 106 humans that were, so somebody measured the body temperature of all of those 106 selected humans and came up with a mean body temperature for the sample to be X bar is 98.26. So this is all given in the problem. And then the other thing that's given is the population standard deviation for body temperatures. Now, why you would know that, I don't know, but they give you the population standard deviation here. In this book, they don't tell you how to do it from a sample standard deviation, so they give you a population standard deviation, which is actually a little magical, but we'll just go with it. They give you the population standard deviation sigma. So I'm going to take these numbers that are given for the sample statistics and plug them into this formula to get my test statistic. So, when I plug into this formula, make sure this is all coming out on the video, I'm going to get that Z naught is equal to, what's X bar minus mu naught? Well, remember, our mu naught, this came from the claim and H1 and H naught. Our mu naught is 98.2 degrees. That's what we claim the mean human body temperature is greater than. So this is the right-hand number in both the alternative and null hypothesis. Just like P naught was the right-hand number in H1 and H naught for the previous example. So, plugging in all these values, mu naught, X bar, N, and sigma, I get that the sample statistic is, parentheses, X bar is 98.26, minus the mu naught, which is 98.2. Make sure you put that all in parentheses. Then go times the square root of the sample size, so it would be the square root of 106, and all of that is divided by the standard deviation, 0.62. Does that all come out on the screen? And all of this is written in the handout. You can see all of this. And if you use your calculator and plug all that in correctly and hit enter, this comes out to be 1.00. Remember, we round all test statistics to 2 decimal places because we're treating them like z-scores. And we're going to use them to get a table value in the very next step. So our tables carry z-scores to 2 decimal places. So to 2 decimal places, it's 1.00. All right, now we move to step 4. All the rest of this, the only difference between these types of hypothesis tests using this flow chart and the ones that test population percentages that's in the other flow chart is the test statistic formula for step 3. All the other steps are identical. So the rest of this is going to be exactly the same as steps 4, 5, and 6 in the previous example. So, we'll just summarize. Step 4. What we need to know for step 4 was, what was the z-score? Well, from step 3, we got the z-score was 1.00. Now we go to table 5. That's the table that comes right after on your cheat sheet. So go to table 5 in the cheat sheet. It comes right after the flow chart on pages 5, 20, and 21. And remember, there's 2 pages for this table. There's a page for negative z-scores and there's a page for positive z-scores. Our z-score is positive this time, not negative. So we have to go to the second page of the table where it has positive z-scores. And remember, we have to look in the left column for the first decimal place. So if you go to table 5 and you look in the left column, you go down to where it says 1.0. And then what? Since the second decimal place is 0, you have to go along the top row until you get to 0.00 in the top row. And then below 0.00 and to the right of 1.0, there should be a table value right there. And that table value is 0.8413. You look that table value up. That means our table value for that z-score, that table value was 0.8413. Make sure that came out in the video. Is that coming out? Okay. So that's our table value. Now, to get the p-value is either equal to the table value or we have to subtract the table value from 1 to get the p-value. And that depends on whether the test was a left-tailed test or a right-tailed test. And remember, that second to last handout in the cheat sheet, if you can't remember, says that when you're a left-tailed test, the p-value is the table value, but when you're a right-tailed test, the p-value is 1 minus the table value. Well, if you go back and look in step 1 of this test, it was a right-tailed test. Since our test was right-tailed, that means our p-value is not this table value, but our p-value is 1 minus that table value. And if you do 1 minus 0.8413, you get 0.1587. And all these calculations are in the handout. So there you go. 0.1587 is our p-value. So that's the part. That ends step 4. Okay. Now we go to step 5. So now we're going to go to step 5. And let's just recall, from step 2, that was our alpha. From step 4, we determined the p-value for this test was 0.1587. Now, remember what? It's the same step 5 instructions. You have to look under p-value method, though. Remember, steps 4, 5, and 6, you have to look under p-value method, not the classical method. So when it branches in the flowchart at step 4, you've got to look at the right-hand branch to read the instructions. They're under p-value method. Now, if you look at step 5 under the p-value method here on page 521, it says, if the p-value is smaller than the significance level, you reject H0. Was our p-value smaller than our significance level? Is 0.1587 smaller than 0.05? No, it's not. 0.1587 is bigger than 0.05. So since the p-value is not smaller than alpha, we're not going to reject H0. Remember, there's only 2 ways to answer step 5. You're either going to say reject H0 or fail to reject H0. If the p-value is less than alpha, you reject H0. That's what happened in the last problem. But if the p-value is not less than alpha, you do not reject H0. So here, we fail to reject H0. Then we go to step 6. And it just says, state the final conclusion. But remember, I made that a little easier, because if you go to the very last page of the cheat sheet, that last page of the cheat sheet is useful for the last step of either flowchart. Doesn't matter what hypothesis test you're doing, you can always use the last page of the cheat sheet to do step 6 of a hypothesis test. And remember, it has 2 questions in this flowchart. The first question says, does the original claim contain the condition of equality? No. In this book, none of the problems have the condition of equality in the claim. Remember, the condition, our claim was a greater than sign. It was the counterclaim that had the equality. So our answer is no again to the first question. And then that scoots you across, and then the next question says, did you reject H0? Did we reject H0? No, we did not reject H0 in this example. No, did not reject H0. So since we did not reject H0, that then leads you into this bottom box. And that bottom box says there is not sufficient sample evidence to support the claim. So the answer here is, you can read it. I'll let you read the final. It says that since we did not reject H0, the answer was no to that last question. So that says that we do not have sufficient sample evidence to support our claim that the mean body temperature of all adult humans is greater than 98.2 degrees. You might say, but wait a second, the sample mean was greater than 98.2. The problem is, the sample mean has to be sufficiently larger than 98.2 at this significant. Remember, sample means are not population means. It's an inferential study. So just because your sample statistic seems to agree with the claim doesn't mean that you have sufficient evidence to support the claim. It's an inferential study. So unless, based on the given significance level, your sample statistic is far enough greater than 98.2 in this case, you're not going to have sufficient evidence to support the claim. It doesn't mean the claim is wrong. It just means that you didn't get statistical evidence that was strong enough to say at this significance level that you have supported the claim. Right? So that's the issue when you do inferential statistics. You can't just say if the sample statistic by itself supports the claim, then the whole test supports the claim. It's because it's an inferential study that you have to go through all this rigmarole and go through all these steps. So even though our sample statistic of 98.26 degrees was greater than 98.2 degrees, it was not great enough by a big enough margin here to guarantee or support at this significance level the claim. So all we say, we're not saying the claim is false. All we're saying is we do not have sufficient sample evidence to support the claim at this significance level. So we just say, at a significance level of 0.05, we do not have sufficient sample evidence to support our claim that the mean body temperature of all adult healthy humans is greater than 98.2 degrees. And once again, now here, we're not going to make you list the error, but in this particular case, because we would have the possibility of a type 2 error, and if you have the possibility of a type 2 error, you can't say what the likelihood that your conclusion is wrong. It would only be in the case of the possibility of a type 1 error where you could actually make a statement about, the likelihood that your conclusion is incorrect due to error would be less than the significance level. That's why they divide them into type 1 and type 2 errors. When you fail to reject H naught, you run the risk that your conclusion could be false, but it would be due to a different type of error. And the only way to know what the likelihood that your conclusion is false due to a type 2 error is if you were given additional information beyond what's given in this problem. And so if you were going to make a statement about error here, the best you could say is there is a chance that your conclusion could be false due to a type 2 error, but we have no way of saying what the probability of that occurring is. But for our purposes, as long as you state the final conclusion, which is we do not have sufficient evidence at this significance level, sample evidence to support the claim, whatever that given claim was, that's all I need to see is your final conclusion here. All right, well that ends the presentation on hypothesis testing. I went through problems 9 and 10 in the video that I did for the practice test, and that video is also going to be on the Facebook page. And you can see me working out one more of each type when I work out problems 9 and 10 from that practice test. And online, like I said, you'll not only get all the solutions typed up to all the problems on this handout over sample problems from hypothesis testing, but you get the solution key to homework assignment 8, which gives more type solutions that are given for all the hypothesis tests in that homework assignment, and the solution key that's online for the practice test for test 3 gives the type solutions for problems 9 and 10 on the practice test. So you have a lot of worked out sample problems online on eCourse of worked out hypothesis test problems of both types. So make sure you also look at the video for me doing the practice test for test 3. If you already know how to do some stuff, then, in all these videos you have the option of fast forwarding or rewinding. So you can always rewind or fast forward through the parts of the practice test that you think you know very well and you've already checked against the solution key. And you only need to focus on the parts of the practice test that are giving you trouble. And remember, I'm going to be on the chat feature on eCourse from 8 p.m. to 9 p.m. Monday through Thursday of next week. So from August 6th to August 9th, I'll be available on the chat feature on eCourse to answer any questions that you might have over any of the videos I've made or any of the other material pertaining to Test 3. So if you have any questions about any videos or anything else, just make sure you get on the chat sometime between August 6th and August 9th from 8 to 9, and I'll be happy to answer any questions you might have. So best of luck on the practice test for Test 3, and this concludes the video for chapters 22 and 23 over hypothesis testing. Thank you.